Hey everyone, Mud Dog Sharky here, and this project kind of fell in my lap today. So this is an old school transverter that converts your 10 meter signal up to a 2 meter signal. And I've been keeping my eyes out for something like this. I've been keeping my eyes out for an all mode 2 meter radio because I want to talk on 2 meter sideband. But this kind of fell in my lap today. And I'm going to make this work with a modern HF radio. I'm going to make this work with an IC7300. And I've been looking at this for a little bit. I've been tearing into the schematic and getting into a few things, and it's definitely possible. So one of the first things I tried is I plugged this into my ICOM just to see if it would receive, and it does. I can hear all my local repeaters on the 10 meter band in the IC7300, so that's good to go. But the trouble is transverting my signal from the IC7300 up to 144 megahertz for transmitting. This wasn't really designed for that radio. It was designed for the FTV-901, and that radio's got some different connections that most newer HF rigs aren't going to have. So I got a plan here, and I'm going to keep this real quick and simple, just because it's a pretty easy project, but I haven't made a video in a while, so I figured I'd jump in here and make one. There has been a lot going on in my shack. I've got a really cool project coming up, and it's been a long time in the making. As you can see, I finally ponied up and got myself a spectrum analyzer. Just because I haven't made a video in a while doesn't mean there ain't stuff going on, all right? I'll get to it. It'll come around, all right? But anywho, let's take a look under the lid, and you can see what's going on in this gizmo. So this is that old school technology where everything's real easy to get to. None of it's surface mount. It's all through hole. They didn't even use double-sided PCBs in here, man. That's pretty cool. Let's look at the output and the input-output connections that we have available to us on the back, and let me explain my dilemma with this unit. So this transverter is actually capable of doing three different bands. It's capable of doing 70 centimeters, 2 meters, and also 6 meters. So this one that I got only had the 2 meter unit in it, which is fine because that's really all I wanted. So what we got over here is an antenna connection for the 2 meter portion. So this is pretty self-explanatory. It goes out to your 2 meter antenna. But we've got a couple of other jacks going on over here. And these ones weren't super self-explanatory. Maybe for some of you guys that are familiar with the older ham gear, maybe this makes sense to you, but it took me a minute to get my bearings on what's going on. So the first thing that struck me as kind of strange is that there's RCA jacks for RF signals. That must be an old school thing. I'm used to SMAs and PLs and SOs and type N connectors and all that good stuff, and haven't really had to send RF through an RCA jack before. Usually that's for the send jack. But what this is this jack up here, external receiver, pretty self-explanatory. It's for an external receiver. The output jack, that one is actually the connect. That's where you connect the antenna port on your radio. So when you've got your 2 meter signal coming in here, it gets stepped down to a 10 meter signal, which comes out of here. Okay, let's move on to the next jack. HF antenna. So that's kind of a pass-through for this port. So if you want to turn this off and talk on your regular HF antenna, that's where you connect that there. This is our typical I/O jack, just some basic stuff to turn this into transmit mode and that kind of stuff. And then we've got our RF in. Now this is the one that kind of threw me for a loop. I wasn't expecting to have to put RF into an RCA jack, and it confused me for quite a while as to why that's there, but I finally figured it out. So the radio that this works with is an old school tube radio, and basically what happens is when this is plugged into the older radio and you turn this on, this being plugged into the older unit, that actually turns off the final output section of the radio. And instead of driving this with the final output section in the radio, you're driving this with the driver section of the radio, which goes into this jack here. I thought that was kind of strange, but it works. It's just not plug and play with any other unit, I guess. Unless the other unit has has that functionality, it's not going to be plug and play. So our modern HF rigs, there's no, driver output on them. So I've devised a way to make this work. And let me take a look at the schematic over here. All right. Helpful if it's right side up. Okay, so this schematic is just for the chassis. It doesn't actually include the transverter module itself, which is fine because we don't need to mess with any of that. If we look up here, we've got our HF antenna jack and our 10 meter out jack. So this 10 meter out, that's the one that's actually connected to your radio. So when this unit is off, that jack is going straight through to your HF antenna. Makes sense. If you don't want to use the transverter, you just want to go straight through to your antenna. The issue is we have to get RF from this jack over to this jack, and we have to attenuate it in between, because I tested it out, and this input is very, very low level. This signal generator right here, which only puts out a matter of milliwatts, was enough to drive this up to the maximum input level. So what we have to do is we have to attenuate the signal coming out of our radio and then get it into here. Alright, so what happens is when you turn the unit on, when you click the power switch, this relay contact immediately clicks over. And what that does is, let me get a pointing device. This wire here is coming from the transverter output. So this is your 10 meter signal that's been converted down, and it's coming out through here and going straight over into your receiver. Now the thing is when you click this over into transmit mode, this 10 meter output is still connected that same way. So if you were to send power through this, it would go straight over here, backwards into your transverter, where you really, probably blow something up if you sent power in there. Now there's actually a safety circuit that detects if there's RF power on here, and it switches this relay back over, but that's kind of irrelevant. I'm going to repurpose this relay basically to make a transmit receive switch with an attenuator in between. So let me see if I can explain how this works. Over here, this is our accessory input. So that's this jack right here, and there's only one pin on there that we really need to be concerned with. That's pin 6. So when you pull pin 6 to ground, that switches this unit over from receive mode to transmit mode. So like I said, when you switch this unit over to transmit mode, this relay stays connected to the output of the transverter. So we don't want that to happen. What I'm going to do is I'm going to make some different connections here, so that when we go into transmit mode, this relay connects our 10 meter output back over to the HF antenna. Maybe you see where I'm going with this. So what I'm going to have it do is in receive mode, this is going to be connected as it is normally, but when we kick the unit over into transmit mode, the power is going to come from our radio, is going to go into this port here. It's going to go through the relay, back out through the HF antenna jack, and then what I'm going to do is I'm going to put an attenuator in between there and this jack down here. And I think it's going to work out great. So like I said, this is really low level. I'm probably going to have to attenuate at least 20 dBs, which is no big deal. If you go on Amazon, you can get these attenuators. Small ones are like 20 bucks a piece, big ones are like 30 bucks a piece. No big deal. So I'm going to give this a shot. I'm going to get in there and make the connections and splice some wires and do what I got to do. And I'll fire this video back up once I got something to show. So minor footnote, as I was in here soldering some wires, I noticed that there's a fried diode and a fried resistor there. So that's R6 and D17. And there's a couple reasons that those may have fried. Turns out that those actually connect, they don't energize unless the radio is plugged in. So what happens is when you turn this on, it turns off the heater. When this is plugged into the 901 radio that goes with it, when you turn on the radio, it turns off the heaters for the final tubes. And this circuit is energized by that power coming from those heater circuits inside the radio itself. So I got a little concerned when I saw that, but it turns out it doesn't even really matter. because it won't be energized since I'm not actually hooking it up to the original radio. I just thought I'd throw that into the video, as you know, you get into these old radio components and there's always something wrong with it, you know. Usually it's the electrolytic capacitors. That's kind of the first thing that you got to get in there and take a look at. But I went in here and checked these out. They look okay. You know, power supply one doesn't look like it's gonna pop or anything. It looks like it's hasn't become misshapen or anything like that. The fuses are good. So, you know, these old radios, man, electrolytics are usually the first thing to go, but I think it'll be okay. I'm going to run it, and if it pops, it pops. I'll get back in and fix it. So, anyway, on with the show. Alright, the modification is done, and it turned out to be pretty simple. So let me show you on the schematic what I did, and then I'll show you where the wires actually go in here. They're kind of tucked in there. It's a little tough to get to, but so what I've done here is pretty stinking simple. First thing I did is I repurposed this port right here. So this is the external receiver output, and I have no use for that. So basically all I did is I disconnected it. So there was just a wire going from there up to this post over here. I just removed that wire and repurposed this jack to connect to the send jack on my radio. So basically when I connect these two contacts in here together, that sets this into transmit mode. So it's kind of just like hooking up a send jack to an amplifier, but in this case it's a transverter. So when you connect those two together, it switches this over to transmit from receive. So that's that jack right there. As you can see, this X, I cut that connection and I ran my own connection down over here. And basically what I did is I took the wire that was going to pin 6 and I just swapped it over to here. That's really all I did there. Pin 6, you pull that pin to ground, it switched this over to transmit mode, and I just disconnected it from the one jack and moved it over to the other. Along with that, I made another modification, and this modification, this diode and this wire here, they connect over to the same spot, over to the where pin 6 used to be, over to the send jack. It's just a diode and a wire. And what this does is when I pull this low, it switches this relay back over to the way it's shown on the diagram. So this is the normal position. When the unit is powered down, it's normally connected this way, so this jack is just straight through over to this jack. When you turn this unit on and it's in receive mode, it switches this jack over to the output of the transverter. And before I made this modification, when you switch it into transmit mode, the relay would stay over in the right hand position. So this jack that's connected to the antenna jack on your radio is still connected to the output of the transverter, and we don't want that, because we have to send a signal from that jack over to here to get it into the transverter. So basically what happens is when we close these contacts and put it into transmit mode, it's going to take the signal coming from our radio, going through here, and it's going to reroute it back out this jack. And what I'm going to do is I'm going to put an attenuator in between here. So your signal's coming from your radio, goes through the relay, out through an attenuator, and into the 10 meter transverter input. So that'll get stepped up to 144 megahertz, 2 meter band. And then that 2 meter signal will come out of the back of the module. So yeah, fairly simple. This diode, it's just a small signal diode, and it's connected to this point for a very good reason. That diode, you may or may not need it, but it's definitely not a bad thing to have that in there. So yeah. Anywho, where are those connections? So the one wire that I changed over from the accessory jack, that one's pretty simple to get to. It's just right over here on pin 6. I disconnected that one, made it a little longer, and brought it over here to here. The other connection was a little tougher to find, a little tougher to get into and solder. Get in here with the flashlight. So under that piece of heat shrink right there, that's my diode, and the two transistors that I'm connected to are on that PCB there, so it's kind of hard to see where it is, but if you look at the schematic, it's pretty easy to figure out. So that blue wire just runs up there and then connects back into the jack that I repurposed. Let me put it back together and we'll test it out on the bench. We have success. It works. This old hunk of junk, it works. And it's doing what I want it to do, which is pretty awesome. So let me show you what we're doing here. Alright, so I didn't want to drag my ICOM all the way over here, so I went and grabbed this thing. Right now it's set at 29 megahertz on FM, and of course we're transmitting into a dummy load, so no worries on that. We're just testing and looking at the spectrum analyzer. So on the output of the radio, we got that coming into here, going into the output of the transverter output. So that's the output jack. And basically what happens is when we turn the transverter on, this signal goes right back out this coax right here and through a whole bunch of attenuators. I didn't have a big enough attenuator, so I had to stack pretty much every one I had. And then that goes back through this coax down here and into the RF input for the transverter. So that's the modification we made. The modification we made is when we're transmitting, the loop goes through here and comes out through there. Alright, so I got to turn this thing on manually with a jumper because I don't have a send jack on this radio. Let me go ahead and do that. Alright, so as I plug it in, we'll go from receive to transmit. Alright, so we're gonna check our input power real quick. Our meter is reading input power. It's a little bright. There we go. Okay, so we got just enough input power to move the meter a little bit. And if we look at the spectrum analyzer, this is the output of our transverter. So that's looking right at 145 megahertz. So that's what's coming out of our transverter. And that makes sense. So we're putting 29 megahertz in, and we have this set to 144 to 146. Oops, sorry. Didn't have the camera pointing there. 144 to 146. So, pretty much all ham radios that are 10 meter, they go from 28 to 30 megahertz. So that's a 2 megahertz range. So basically what this does is it takes that 2 megahertz range and moves it way up in the band into the 2 meter range. So 28 megahertz would be 144, and 30 megahertz would be 146. So if we want to go into the upper half of the 2 meter band, we just select this switch over here, and then 28 megahertz becomes 146, and 30 becomes 148. So let's take a look what we got going on right now. We got the radio in FM mode. So if I key up, it just moves a carrier. Let's zoom in a little bit and take a look at the modulation. Let me see, what do we got here? Let's zoom in real close. Okay. Let's zoom in a little bit farther. Actually, no, that's about right. Okay, let me turn up my mic gain here. Audio. 1 2 1 2, test test 1 2 1 2 1 2. Let me adjust my bandwidth a little bit and see if we can really see what's going on here. Check check 1 2 1 2 1 2. Audio 1 2 1 2 1 2 1 2. That's perfect. Maybe I can zoom in a little bit more. Audio 1 2, check 1 2 1 2 1 2, check 1 2 1 2 1 2. Alright, well that's what our FM signal looks like, transverted through an old hunk of junk from 10 meters up to 2 meters. So that's really cool. This sucker works with sideband, works with CW, AM, FM, pretty much any kind of signal you can throw at it, it'll transvert it up there. It might even work with FT8 or something like that. I'm sure it would. I'll probably never try it though. Another cool feature about this unit is it's got the repeater offset. So if you flip this switch, it automatically steps your transmit up or down by 600 kilohertz for the repeater offsets, which is super cool. I think I'm definitely going to get some use out of this thing. It's got real practical use in my shack, and I'm glad I stumbled across it and opened it up, fixed it, and made this video today. But anyway, I'm Mud Duck Sharky, and I'll catch you guys around.